Do you have any doubt from last class to any of you? Okay, tell me the last topic, what we had done last class.
The last topic was reaction time. We did one of the questions.
Okay. Reaction time and stopping distance. Okay. I'm giving you one more problem related to equation of motion. Try to simplify. A body covers 9 meter in third second and 14 meter in fifth second. Find initial velocity and acceleration. Try to solve. I'm giving you some hint. Samara, just tell me whether this particular time is defining about period of time or defining you just consecutive time gains.
So can you repeat?
Is this time, is a time interval starting from 0 to that given time, or this is time interval between consecutive seconds? In last class, I had explained you how to use any given equation related to given term and the question, whether it will defining you starting point to that given time or a period of time from starting to that given time, or the time interval between any two consecutive seconds. So in this problem, we have third second, not as 3 second, fifth second, not as 5 second. So this time is basically time between two consecutive seconds. So you will use S nth is equals to U plus A over 2 times 2n minus 1. So in first part, we have 9 meter as S and n is 3. So you will get first equation. Similarly, for the second part, S nth is 13 and n is 5. So you get second equation. On solving these two equations, you get U and A. Is it clear?
Yes, sir.
Okay, try to solve. Just see how to formulate equation. S in it, for the first part is 9 meters, so it will be 9 is equals to u plus a over 2 times 2n minus 1, where n represent the time. Here we have third seconds, where n will be equals to 3. 2 into 3, 6 minus 1, 5. So you will get first equation as this. Similarly, if you write for the second part, it will be 13 meter is equals to u plus a over 2 times 2n minus 1, where n is 5. So 2 into 5 is 10, minus 1, 9. Just subtract these two equations, you will get acceleration. And then on putting the value of a in any given equation, you will find u. Try to solve. Just subtract these two equations. So it will be like this. Do you have any doubt while solving? Maria?
Sir, 1 second doing.
Good, Maria. Now put this value in any of the equation, you will get initial. Myra, Sita, Aisha, just send the answer. Good, Maria.
Can you please solve and show?
If you subtract these two terms, 9 minus 13, you will get minus of 4 is equals to u minus u would cancel out, so it will be 0, plus a by 2 as common. So it will be 5 minus 9, that will be minus 4. This minus 4 and this minus 4 will cancel out each other. So you get A is equals to 2 meter per second squared. Is it clear?
Yes, sir.
Now, if you put the value of A in any of the given equation, let's say first equation, so it will be 9 is equals to U plus A over 2. That means 2 over 2 into 5. So 2 and 2 would cancel out. Move this 5 to the other side, you will get 9 minus 5, which is equals to 4 meter per second. Good, Aisha. Is it clear for you all? Sabita?
Yes, sir.
Okay. Safan, I think you are absent in last class.
Yes, sir.
I just explained equation of motion, speed, distance, and time, these relationships. Okay, we just write it down. Have you done till this part?
Yes, sir.
Safan?
Yes, sir.
Now, I'm defining you the next concept of this particular chapter, that is free fall or motion with gravity. Just use some of the concept first. Take the point of thrown of a body to the origin always. Take the point of thrown of body to the origin. On the basis of this origin, all upward quantity, whether it will be velocity, acceleration, height, should be positive, and all of downward quantity would be negative always. Since gravity always acts towards surface of Earth or always in downward direction, so taken as negative always. So gravity is taken as negative always. Next is body always acquire the velocity of system whose it is a part. Let's say body is placed in a car or a moving car. So velocity of body must be equal to velocity of car in which it is placed. So object will acquire velocity of system whose it is a pound. And this whole concept just neglect air resistance. So air resistance is neglected. Any doubt till this to any one of you? Safan, is it clear?
Sir, could you explain object will acquire velocity of system once again?
Let's say if a body is placed in any moving vehicle, let's say if you are sitting in a car, so if car is moving with some speed, let's say 10 meter per second, 20 meter per second, so your velocity and velocity of car would be same or different. It should be same. Otherwise, you will cover different distance and car will cover different distance in same interval of time. Or you will say these two different body will move along different path or along different position. So always object acquire the velocity of system whose it is a bound. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Next is suppose this is surface of Earth and if a body is thrown upward from this point with some initial velocity u, so it will move along this direction and after attaining some height, it will return back to this point with some velocity, let's say v. At the highest point of any projection, velocity of object would be zero. So velocity of object is zero at its highest point. But acceleration of body still would be along downward direction, so it will be minus of g. So there will be a question to define or give an example where object will have zero velocity, but still it is accelerating. So you will say at the highest point of free fall. Is it clear?
Yes, sir.
Now, this particular object would have taken some time to ascend from bottom to this particular highest point. This time is called time of ascent. Similarly, it will take some time to descend from this point to this point. In this gravity, for same horizontal level, time of ascent and time of descent always equal. For same horizontal level, first time of ascent should be equal to time of descent. Total time of flight, that is total time taken by the ball to cover this entire path in air is called time of flight. So it should be equal to time of ascent plus time of descent, or you will say it will be 2 times of time of ascent or 2 times of time of descent. So it will be 2 times of time of descent. Is it clear?
Yes, sir.
Safan, any doubt? Myra,
No, sir.
next is at same horizontal level, let's say at this point. If object has velocity along this direction, let's say v1, and while coming down, it has some velocity, let's say v2. If air resistance is neglected, and if you are considering same horizontal level, then the velocity, these two velocity must be equal. They may be in opposite direction due to which they have different sign, but still their magnitude should be equal. So next, for same horizontal level, velocity 1 in magnitude, velocity 2 in magnitude should be. Is it clear till this part?
Yes, sir.
Just write it down. I'm giving you some examples related to this.
Done, sir.
Stefan, have you done?
One second, sir. Done, sir.
Ikra, you may take a screenshot.
Yes, sir.
Let's say boy in upward direction and after 4 seconds. Find first velocity of projection, maximum height it will attain, take g to be 10 meter per second square. So how to solve it? I'm giving you some hint. Let's say this is your surface of earth from which ball is thrown upward. So it will move along this path and it will return back along this path. So it must be projected with some initial velocity u. At its highest point, velocity would be 0. I have defined u in the previous part. Take the point of thrown of body to the origin. So it will be origin and this point. So all of the quantity which is in upward direction must be positive and along downward direction must be negative. So u, which is going along upward direction, so it will be positive. Height attained by the body, which is also in upward direction, so it will be again positive. And gravity always act along downward direction, so it will be negative. So next is the total time taken for this entire journey is 4 seconds. So it will we have given 4 seconds as time of flight. So we can break this time into two parts to get time of ascent and time of descent. So it will be time of ascent is equals to time of descent, and which would be equals to time of flight divided by 2 by using this concept. As time of flight is 2 times of time of ascent or 2 times of time of descent, so you will write time of ascent is equals to time of flight divided by 2. From this, you will define or you get time of ascent. Now, write equation first, which is equals to V is equals to U plus A times T. V is at highest point should be 0. You have to calculate. A is nothing but gravity, which is along downward direction, so it will be negative. And T is time of ascent, which you have calculated from this equation. Just put all of these values and try to find U from this equation. Is it clear?
Yes, sir.
Try to solve. Similarly, using third equation, you will find height. To solve, uh, Mariam, just send me your answer. Samara. Mariam, just check your calculation. Ikra, I think you have taken gravity to be positive.
Okay, sir. Let's
You have to take gravity to be negative. As gravity always acts along downward direction, so it will be opposite to, or it is along negative y coordinate, so it will be always negative. So v is 0 for the highest point. U, we have to calculate. Acceleration is minus g, which is equals to 10. And time of ascent is just 2 seconds. So if you solve, you will get 20 meters per second. Now put this value in this equation, you will get height attained by this object. Sabita, just check your calculation. Samara, I think you have taken gravity to be positive. Safa, have you solved? Good graph. All these values in this equation, v is at highest point, so it should be 0. Good, Mariam. We have calculated as 20 meters per second, so it will be 20 into 20 plus times a. A is gravity, which is minus 10, and s is height, which is along positive y-axis, so it will be taken as positive h. Now move this whole part to the other side, it will become 20h is equals to 20 into 20. So h is equals to just 20 meters.
So when an object is falling from a height, so the gravitation will be minus. Is it right?
Yeah, I've just defined you just these three different statements. First, take the point of thrown of any object to be origin orbis, and on the basis of that origin, upward all quantity would be positive and downward all quantity would be negative. Since gravity always acts along downward direction, so it will be taken as negative always.
Yes, sir.
Safan, any doubt till this part?
No, sir.
Aisha? Okay. This next concept in this part is dropping of a body. As I have defined you, object always acquire velocity of system whose it is a part. So let's say there is a building. This is ground. If a body is dropped from this point, it is just dropped from this building. So this building is initially at rest or it is not movable. So you'll say this object must have zero initial velocity as this object has dropped from this stationary building. So on the base of system as building, initial velocity of object would be zero. So u is equals to zero. All of the measurement of this body is from this origin. Upward quantity would be positive and downward quantity would be negative. So height of this building from this origin would be along positive y-axis or negative y-axis. Safan,
Yes, sir.
height of building from this origin is along positive y-axis or negative y-axis.
Negative 5.
So height will be taken as negative. So h will be negative. Gravity always acts along downward direction. So it will be again taken as negative. Now just use these two terms in any of the given equation, you will find your answer for time, final velocity of hitting the ground, and so on. Next is, suppose ball is dropped from any hot air balloon. Say a hot air balloon is ascending. And there is a body inside it. Let's say this is ascending at some initial velocity v0. Now this body is dropped from it. Let's say drop into air. Samara just define in which direction this body will move initially, upward, downward.
Downward.
Okay, Safan, would you like to answer? In which direction this body will move initially? Upward or downward? Mariam?
Downward.
Okay. Just tell me, what would be the initial velocity of this particular object? Ikra?
Zero.
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 Just read out this statement. Object will always acquire velocity of system whose it is a part. So this object is initially a part of this hot air balloon, which is ascending upward at this much velocity. So this object must have velocity equals to velocity of system whose it was a part. Is it clear?
Yes, sir.
So it will have some initial velocity v0 in which direction? In upward direction, due to which it will move to some height and then return back to ground. Like this. Is it clear to you all?
Yes, sir.
Yes, sir.
Samira, any doubt?
So can you repeat?
Okay. Since I have defined you, object always acquire velocity of system whose it is a part. So this ball was initially part of this hot air balloon, which is ascending at this much velocity along upward direction. So this ball would have this much velocity along all upper direction, due to which it will move to some height along this way, and then it will return back to the ground. Is it clear?
Yes, sir.
So just draw this point of thrown as origin. Upward all quantity would be positive and downward all quantity would be negative. So let's say height from this point to reach its maximum point to be in upward direction. At this point, or the highest point, velocity of body would be 0. So we have two different paths for this motion. First, h, which is in upward direction, so it will be positive. Initial velocity of this particular object, which is also in upward direction, so it will be positive. Gravity always acts along downward direction, so it will be negative. This is for this point to this point motion. Next, if you have to define motion for this path to hit the ground, so it will be, let's say, height at which the ball is dropped from the balloon is capital H. So this capital H is along downward direction or along negative y-axis with respect to this origin. So capital H would be negative. Initial velocity would be same as for this part, so it will be positive, and acceleration would be always negative. Is it clear?
Yes, sir.
Yes, sir.
Safan, any doubt?
No, sir.
Okay, just write it down. I'm giving you one example related to this.
Done, sir.
We are done.
Yes, sir.
Sabita, let's say a hot air balloon is ascending at 12 meters per second. Drops a ball when it is 65 meters above the ground. Find first time of flight and second velocity with which it will hit the ground. Just try to solve using the last concept. Good, Mariam. Let's say this is your hot air balloon, which is going up some initial velocity 12 meter per second and drops a ball at this point. So it will have initial velocity equals to velocity of system, that is hot air balloon from upward direction. So it will be 12 meter per second, due to which it will ascend to some height and then it will return back to ground. So take this particular point to the origin. All of the upward quantity would be positive and downward quantity would be negative. So here u will be positive 12 meter per second. Since this height at which the ball is dropped from ground would be along negative direction from this origin, so h will be taken as minus 65. Gravity is always along downward direction, so it will be taken as negative. So using second equation of motion, that is S is equals to ut plus half at square. Put the value of S to be minus 65, U to be 12, and A to be minus 10. And just solve this quadratic equation, you'll get time. On solving it, just put all of the values in first equation of motion. You will get velocity with which it will hit the ground. Is it clear to you all?
Yes, sir.
Mariam, just check your calculation. Sabita, just check your calculation. If you put the value of S to be minus 65, is 12 into t plus half, acceleration is minus 10 into t squared. So this 10 will cancel out. It will be 5 times t squared minus 12 times minus 65 is equals to 0. So you will get 65 into 5 as factored. So it will be 30 into 5. 5 into 5 would be 25 and 13. So you will break it as 25t plus 13t minus 65 is equals to 0. Take out 5 as common, 13 as common. So you will get t minus 5 and 13t plus 1. On solving, you will get t is equals to just 5 seconds. Is it clear, Ram?
Yes, sir.
Yes, sir.
Now put this value of time in the second equation, the first equation. You have initial velocity, acceleration, and time. Mariam, I think you have done well. So far, just send me your answer for the second part. Put the value of u, a, and t and simplify it. Samara, gravity would be negative. Good, Ram. Good, Samara. Good, Sabita. A is equals to minus of gravity, which is equals to 10. So if you put all these values, u is 12 positive, acceleration is minus 10, and time is 5. So on solving, you will get minus 38 meter per second. This minus is defining you nothing but direction in which this body will move. So it will be along downward direction. And its magnitude is 38 meter per second. Is it clear, Safan?
Yes, sir.
Try to solve one more part. A ball is dropped. A ball is dropped from 45-meter tall building. Find velocity and time of flight. Velocity means velocity with which it will hit the ground, and time of flight. This is your object. Take this point as origin. All upward term would be positive, all downward term would be negative. Put all the values in second equation of motion, you will get time of flight. And then on putting all the values in first equation of motion, you will get velocity of hitting the ground. Just use this equation, you will get time of flight, and then put all the values in first equation of motion, you will get final velocity of hitting the ground. Good, Maria. Good, Maria. Good, Sabita. Iftara, just check your calculation.
Yes, sir.
Samara, just check your calculation. Good, Sabita.
Yes, sir. I got my mistake.
Safan, answer. Good, Iftara. Just see, we have S is equals to minus 45 meter. U is 0, so this whole term would become 0, plus half. Acceleration is minus 10 into t square. So this 2 and 10 would cancel out. So if you move minus 5 to the other side, you will get minus 45 divided by minus 5. So it will be 9. Here we have t square. So move this square to the other side, you will get t is equals to the root of 9, which is equals to 3 seconds. Now put this value of time in this equation, you will get velocity of hitting the ground. Is it clear, Samara?
Yes, sir.
Safan, any doubt?
No, sir.
Try to find final velocity using first equation. Good, Safan. U is 0, acceleration is minus 10, and time is 3. So it will be minus 30 meter per second. Good, Samara. So this is how we solve equation of motion or free fall using this concept. I'm defining you some more relation related to this. There's one term which is called Gallius relation of odd number. It is not valid only for vertical or free fall. It will be always also valid along horizontal path. Let's say if a body is dropped from some height, from this point, so the height traveled or covered by this object for equal time gap. So we have to calculate height covered by this body for equal time gap. I have assumed body is dropped. So its initial velocity at this point would be 0. We have to calculate height covered by the body for equal time gap. So using second equation of motion, S is equals to ut plus half at square. S, which is along downward direction, so it will be negative. U is 0. Acceleration is minus g into time taken is t square. So this minus and this minus will cancel out. So you will get h1 is equals to half times gt squared as first equation. Is it clear till this part?
Yes, sir.
Yes, sir.
Similarly, if you want to calculate second height, h1 is height from this point to this point. Similarly, we have to calculate h2 from this point to this point. So how to define it? I had explained you in the last part of equation of motion, first, second, third. These all three equations is valid from starting of the journey till that given interval of time. So it will define you for period of time. So if you have to calculate only this part from this point to this point, so first of all, you have to calculate this height from this point to this point, and then subtract this from this, you will get h2. Is it clear? So let's say this particular height to be capital H2 in negative direction. U is 0 and gravity is minus. So the total time taken from this point to this point is 2 times of d squared. So it will be h2 is equals to half g square of 2 is 4 times d squared. But you have to calculate h2. So this will be equals to h2 minus h1. If you subtract these two terms, you will get 3 times of half gt squared. Is it clear?
So what is capital H?
Capital is the total height from the starting of the journey till this point. Since this equation, it means from the starting of journey till the end point. Since the journey is starting from this, for which you have initial velocity to be 0, total time taken from this point to this point is t plus t, which is 2t. That's why I have taken this height from this point to this point as capital H2. You have to put on this side between this point to this point. So just subtract this by this. Is it clear? Samira, is it clear?
Yes, sir.
Stefan, any doubt?
No, sir.
Similarly, if you have to calculate this height, let's say h3, so that you will be able to calculate this height. So h3 would be equals to h3 minus h2. If you calculate h3, you will get half g, and total time taken from this point to this point would be t plus t plus t, which is 3t. So square of it will be 9 times of t square minus h2, which is nothing but 4 times of half gt square. So if you subtract these two parts, 9 minus 4, you will get 5 times half gt square. Now just compare equation first, equation second, and equation third. Is there anything which is common to all of these three terms? So you will say half gt square is common in all.
Yes, sir.
So if you divide all of these three equations, you will get ratio as 1:3:5. So from this, you will conclude for equal time, height covered by body h1, h2, h3, and so on to hm would be equals to, in the ratio of odd number, so it will be 2n minus 1. So if someone asks you to find height in 5th second, so just put the value of n to be 5 in this part. So you, among solving, you will get 2 into 5, that is 10,
Yeah.
minus 1, 9. So it will be 1:3:5:7 into 9 parts. Is it clear?
Yes, sir.
Just write it down.
Done, sir.
This relation is also valid for uniformly accelerated motion along horizontal line. If path is horizontal and initial velocity is 0, then distance covered by the body must be in ratio of 1:3:5. Have you done till this part?
Yes, sir.
Safan?
Yes, sir. 1 second.
Done, sir.
Done, sir.
Sumara? Have you done?
Yes, sir. Done.
Ikra?
Done, sir.
Okay. Similarly, I'm giving you one more relation related to this. Let's say if you have body jump from some height. So if you have to calculate ratio of time to cover equal height. This is your object, which is drop from a high building. Let's say this displacement is h, h, and h. So the time taken to go from this point to this point is t1. From this point to this point is t2. And from this point to this point is t3. So just remember to cover equal height while free falling. The ratio of time T1 is to T2 is to T3 and so on to Tn. So it should be equals to 1 is to root 2 minus 1 is to root 3 minus root 2 is to so on root n minus root n minus 1. Just remember this relation. It will be asked directly to define ratio of time to cover equal height or ratio of height to cover or ratio of height traveled by same amount of time.
Done.
Okay.
Done, sir.
Safan, done?
Yes, sir.
Next topic is non-uniformly accelerated motion. It means if you have displacement, velocity, acceleration as some variable term, time dependent, position dependent, or velocity dependent function. So how will you solve it? So I'm defining you some concept. First is instantaneous velocity. Instantaneous means velocity of a particular object at given instant of time. So it means velocity of a body at given instant of time. Let's say velocity is nothing but change in displacement by time taken. So it will be delta x over delta t. Now, if you have to make this particular term to be instantaneous, or it will be, or you have to take this particular difference to be very small, that it tends to just zero. So we use limit delta t tends to zero. Now, in mathematics, this whole term will define you nothing but differentiation. So it will be differentiation of x with respect to time. So this velocity, which is nothing but velocity at a given instant of time, is termed as instantaneous velocity. Is it clear to you all?
Yes, sir.
Yes, sir.
Samara, any doubt?
No, sir.
Similarly, if you have to calculate average velocity, so it will be x at t final minus x at t initial divided by t final minus t initial. X is defining nothing but position or displacement. So average velocity is net displacement by time taken. So it will be x2 minus x1 by t2 minus t1, or it will be x at final time or x at initial time divided by t final minus t initial. There is one more relation to find average velocity. So it will be like this. If there is equation itself in terms of velocity and you have to calculate average velocity, so just use this expression. Or in general, I'm giving you one more relation. To find average of any quantity, let's say f. So it will be f times d divided by integration. This particular average is based on time, so you call it as time average function. And suppose if you integrate this particular function with respect to x, then that average is called as space averaged term. Is it clear?
Yes, sir.
Next is, if you define instantaneous acceleration, it will be a is equals to dv by dt. But this formula will be valid only for velocity to be time dependent function. So if velocity is time dependent, so just use this expression. Otherwise, if velocity is position dependent, just use this expression. Now to get average acceleration, just use velocity at final time or velocity at t final minus velocity at T initial divided by T final minus T initial. Or if there is only acceleration, just use this expression to get average value. I'm giving you some example related to this whole part so that it will become more clear to you. Just write it down first.
Done, sir.
Done, sir.
Done, sir.
Done, sir.
Safan, done.
Done, sir.
If displacement is equals to T cube minus 4T square plus T minus 2. Fine. First, initial velocity. Second, velocity at T is equals to 2 seconds. Third, average velocity between T is equals to 1 second to T is equals to 3 seconds. Next, acceleration at T is equals to 3 seconds. Try to solve. First, differentiate this function, you will get velocity. I think you all have remembered how to differentiate any function. If you have x raised to n, and if you have to differentiate it, it will be n times x to the power n minus 1. Just use this concept. Since we have x, which is displacement, so just differentiate it. You will get velocity. on any doubt differentiating? Sabita, any doubt?
No, sir.
Raised to 3. So according to this rule, if we differentiate it, you will get n x to the power n minus 1 minus t raised to 2. So if you differentiate it, you will get 8 times t to the power 1 plus 3 t raised to 1. So its differentiation would be 3. And 2 is any constant term. So if you differentiate it, you will get 0. So this will be your velocity at any instant of time. So in first part, you have to solve initial velocity. Samara, just tell me, what do you mean by initial velocity? Maria,
It's u.
it's you. At
It
what
is
time it will
velocity
be
before the acceleration,
before the acceleration?
effect of acceleration.
Ikra, what do you mean by initial velocity?
So could you repeat?
What do you mean by initial velocity?
Velocity?
Initial velocity, initial velocity.
The velocity at the starting position.
So at what time it would be?
So your voice is not clear.
Tell me the time at which this would be.
I'm not
So
sure,
you'd
sir. I
say,
don't know.
initial velocity is velocity of the body at initial instant. It means at t is equals to 0. Is it clear? So if you have to calculate initial term, so just put t to be 0. You will get initial velocity. Just put in this term, so you will get u is equals to 3 meter per second. Is it clear, Mariam?
Yes, sir. Sir, could you repeat the definition?
Initial velocity means velocity at initial instant of time. It means at t is equals to 0. So you'll say velocity of a body at t is equals to 0 is called initial velocity. Similarly, if you have to find initial acceleration, it means acceleration of body at t is equals to 0. So for any term, if you have to calculate the initial value, just put the value of t to be 0. Is it clear?
Yes,
Yes,
sir.
sir.
Now, the next part is to define velocity at t is equals to 2 seconds. So just put the value of t in velocity to be 2 seconds. At t is equals to 2 seconds, velocity would be equals to 3 into 2 square, that is 12, 8 into 2 is 16 and 3. So 12 plus 3, 15 minus 16, which is minus of 1 meter per second. So it will be velocity at t is equals to 1 second. Is it clear?
Yes, sir.
Now the third part is to define velocity average between t is equals to 1 second, t is equals to 3 seconds. Just value of t initial, which is equals to 1 second, the expression of displacement. So you will get initial displacement. Similarly, if you put the value of t final to be 3 seconds, you will get displacement final. Just put the value of ti and tf in this first equation, you will get xi and xf. And now on putting all these values in this expression, you will get average velocity. Is it clear?
Yes, sir.
Try to solve. Okay, Samara, try to solve the other part. I'm solving. Let's say if you put ti to be 1 in this first expression, you will get 1 minus 4 plus 3 minus 2. 4 minus 4 will cancel out, so you will get minus 2 meter. Similarly, if you put t equals to 3 seconds in this expression, you will get q, which is 27, 3 square, 9 into 4, 36. 27 minus 36 plus 9 minus 2. So 36 and 36 will cancel out, so you will get just 2 meters. Now put all the values in average velocity. So V average is equals to x final minus x initial divided by t final minus t initial. So it will be minus 2 divided by 3 minus 1. So it will be 0 meter per second. Samara, is it clear?
Yes, sir.
Now the next part is
Sir,
to
could you
define.
explain again? I got disconnected.
Okay. If you put ti to be 1 second in this expression, you will get x initial as minus 2 meters.
Yes, sir.
Similarly, if you put t final to be 3 seconds in this expression, you will get x final again to be minus 2 meters. Now, for average velocity, we have a formula x final minus x initial divided by t final minus t initial means net displacement divided by time taken. So x final is minus 2 and x is initial is also minus 2. So these two terms would cancel out. So you will get just 0 meter per second as average velocity for the interval from 1 second to 3 seconds. Is it clear, Ikra?
Yes, sir.
Now we have velocity, which is 3t square minus of 8t plus 3. Whether this velocity is position dependent function or time dependent function. Sabita?
Sir,
Is velocity time dependent function or velocity dependent position dependent function?
it is depend on question.
This velocity here is time dependent function. So I've defined you. If velocity is time dependent, so just differentiate it with respect to time. So you will get acceleration as dv over dt. But if velocity is position dependent function or x dependent function, so acceleration would be equals to v times dv by dx. So just differentiate it with respect to time. So you will get 3 as constant t square. So it will be 2t raised to 2 minus 1 minus 8 as constant t raised to 1. So it will be 1t raised to 1 minus 1 plus 3, which is just a constant term. So its derivative would be 0. On solving, you will get 6 times t minus a. Now put the value of t to be 3 seconds. You will get acceleration as 6 into 3 minus a, which is equals to 10 meter per second square. And in this part, if someone asks you to find initial acceleration, so put e is equals to 0. So initial acceleration would be equals to minus 8 meter per second square. So this will be termed as initial acceleration of this particular object. Is it clear to you all till this part?
Yes, sir.
Yes, sir.
Safan, any doubt?
No, sir.
You just write it down.
Done, sir.
Done, sir.
Done, sir.
Safan, done?
One second.
Sabita?
Done, sir.
Okay. If velocity is 5 times root x, find acceleration. So first of all, you have to define this velocity, whether it is time dependent term or position dependent term. Here we have x dependency. So for x dependency term, acceleration is equals to v times dv over dx. So first of all, differentiate this particular term with respect to x. So it will be v is equals to 5. Root of x can be written as x raised to half. So on differentiating it with respect to x, it will be n x raised to n minus 1. And on simplifying, you will get 5 divided by 2 root x. Now put these two values in this expression, you will get value of acceleration. Try to find. Put the value of each term, you will get acceleration. Good, Maria. Good, Ikra. Put the value of V as it is, this part. And next, value of dv over dy as this part. So far,
Yes, sir.
what is the value of V in this equation?
5 root x.
5 root x into, and the value of d by dx is
5 by 2 root x.
so root x and root x will cancel out. So you will get 5 into 5, that is 25 over 2. So it will be 12.5 meter per second square. Is it clear? Sabita, any doubt?
No, sir. No, sir.
Samara, any doubt?
No, sir.
Okay, so just revise this whole concept and try to do more and more problems related to motion under gravity and this non-uniformly accelerated motion using calculus method. Okay,
Yes, sir.
okay then.
Thank you, sir.
Thank you.
Bye, sir.
Thank you, sir.
Thank you, sir.
Thank you.